First function, and we'll consider the graph here, or we can just plug in the 1 if you'd like to. As x approaches 1 from the right, we look and see where is x a little greater than 1. Greater than 1, it looks like it's defined to be negative x plus 4, so this is going to be the limit as x approaches 1 from the right of negative x plus 4. And that's going to be, substitute the 1 for x, and that's what? 3. Visually, as x approaches 1 from the right, points on the graph are approaching a point whose y-coordinate is 3. So the y-coordinates of those points are approaching 3. So the value of the limit is 3 as we go from the right. What do we go from the left? This equals the limit as x approaches 1 from the left of that other rule, x. When x is a little bit less than 1, to the left of 1, it's defined by the expression x. So this equals what we get when we take 1 and substitute it for x, and that's 1. So as we're approaching from this direction, the point there is the point 1, 1, so the y-coordinates are approaching 1. Now, it will belabor the point unnecessarily if I repeat a lot of that. So basically, what I'm saying in the other two examples, the limit of g of x as x approaches 1 from the right, because we're approaching the point, and I should go with an open circle there, 1, 3, that's equal to 3. Here the graph is approaching the point 1, 1, so that's equal to 1. Doesn't matter that g of 1 equals 2. Limit doesn't care how the function is defined at 1. It's what's it approaching. Same thing here. The graph is approaching the point 1, 3. So as x gets close to 1 from the right, value of that limit's equal to 3. Here the graph is approaching the point 1, 1. So as x gets close to 1 from the left, y-coordinates are approaching 1, so same thing. Now the function happens to be defined to be 3 there, but the limit doesn't care. It's unaffected by that. So 3, 1, 3, 1, 3, 1. And of course in all three of those cases, even though it did not ask, the two-sided limit fails to exist.